Alright, so today we're going to be talking about how to set up an LP problem in Excel and use Solver to solve it. So I went and grabbed a problem from one of our worksheets. It goes, a workshop has three types of machines, A, B, and C. It can manufacture two products, 1 and 2. All products have to go to each machine, and each one goes in the same order, first to machine A, then B, then C. The following table shows us how many hours are needed at each machine per product unit, and then our total amount of hours that we have available for each machine. So it looks like we're making tables and desks here. And with the first machine, machine A, it's going to be 1 hour for both tables and desks. We have 10 to give. For machine B, it's going to be 3 hours for a table and 2 hours for a desk out of our 12 total available hours. And machine 3, we're going to have 2 hours per table, 4 hours per desk, and 28 total hours available for machine C per week. So now we're looking here, the profit per unit sold is $200 for tables and $100 for desks. Formulate and solve an LP problem to maximize our profit. So we're going to start off here with labeling our two variables x and y, which in this case are just going to be tables and desks. We're going to go tables and desks. And we know that for each, I'll go ahead and write the profit next to it here. For each individual table we produce, it's going to be $200 of profit, 200, and for each desk, it's going to be 100. And now I'm going to go ahead and label these as our variable cells right here. And make that a little larger. And for now, these are just going to be zeros. This is going to be where Excel Solver plays with numbers, and these are going to be the two cells we're going to let it toggle for how many tables we make and how many desks we're going to end up making. So now we can come down here and we can go ahead and just label our machines here, A, B, and C, and then tables, desks, and our total hours available. So these are all just coming straight off of our table from the problem here, where machine A is going to use 1 hour per table and 1 hour per desk. Machine B is going to use 3 hours per table and 2 hours per desk. Machine C is going to use 2 hours per table and 4 hours per desk, where each of these have a total of 10, 12, and 28. So now we have our table brought in here. We have our initial variable cells labeled along with the profits going for each of these here. So the next logical thing to do would be to set up we need to find a way in order to determine how to meet our constraints with our total hours over here. So what we're going to do is, very similarly, we're going to have tables and desks again. But this time, since we're dealing with hours down here, which I can actually even label right here, hours, we need to account for the fact that however many tables we're making is going to be scaled by the amount of hours it's going to take to make one table. So for these here, this first cell, since we're talking about tables for machine A, it's going to be the product. So we're going to do equals product. And we're going to multiply the number of tables, comma, by the number of hours per table. What that's going to do, and actually what you should do, when you type the variable cell part, put a $sign before the B and before the 4, or whatever the letter and number is. What this does, I'll show you in one moment here. So now this is our 0 because we have 0 tables at 1 hour per table. If this was 3 tables, then it would be 3 down here. It updates automatically. Now we'll keep that at 0. And now what we're going to do is for the 3 cells we have here, we can just drag this down and it takes the formula with. But since we put those $signs in, you can see that the B4 stays the same. It just kind of locks the variable in, while the other one changes from B7 to B8 to B9, which works perfectly with our 3 rates up here. So now very similarly for desks, we're going to go equals product. We're going to go $sign C4, which is just the cell right up here, the number of variable units of desks, comma, and then our rate for the machine A desks, which gives us 0 again. And if we move this downwards, it's going to copy that formula and change C7 to C8 and C9 respectively. So again, if we make this 2, it's going to put in values here scaled by the amount of hours per table. And same goes for if we do it for desks. We're going to have 2, 4, and 8, which is just 2 times 1, 2 times 2, 2 times 4. So now the last thing we have left to do in our setup process over here is our optimal solution cell. What I'm going to write is maximize above it here, and we're going to go down one. And what we're going to do is the sum product of, so what's going to happen here is we're going to take these two cells, our profits, and we want to multiply them by the amount of tables and the amount of desks. So we're going to have B3 through C3 for our profit values per unit, and then our total number of units on the other side of the sum product here. What that's doing here is it's putting us at 0. But if we were to make one table here, since each table is a profit of $200, it's just going to be 200. Whereas if this was a 2, it would be 400. And if we had one desk, it would be 500 total. It just kind of works like that. So again, we're going to make these zeros for now. Now what we're left to do is we go to the Data tab up top, over to Solver. And this is where the fun stuff comes in here. We want to make sure this is set to max rather than min because we're trying to maximize our profit. And our objective function, like we said, the sum product was right in this cell here. Our variable cells are going to be right over here for the number of tables and desks that we produce. Now we need to add our constraints. The only constraints we're dealing with here are the hours that we're limited to for machines. Or actually, you know what? I did skip something real quick here. Let me step out. We're going to talk, so we have our total hours that we're allowed to use, that were allocated here, and we need to know how many hours we are using. So I'm going to write hours used. And all this is going to be is just the sum of the two cells here. So it's just, each of these were products already. So for example, in this column, we're doing however many tables times 1 hour per table, puts us here. And however many desks times 1 hour per desk goes here. So we add these up and it gives us our total number of hours for machine A. And then very similarly, I can just drag this down. That's going to give us our total hours for machine B and for machine C. So now, sorry, I forgot that step. We can go back into Solver here and set up our constraints, which is going to be, we know that we can't use more than our total hours. So we're going to say our hours used for machine A is less than or equal to our total hours allowed for machine A. We're going to add that in. Then for machine B, our total number of hours used less than or equal to our allocated hours. And then similarly for machine C, our total number of hours used out of our allocated hours. Now, again, we have our objective function set to maximize our variable cells, which are right up here, and then our 3 constraints for our 3 machines. We can keep this checkbox here to make our constraints, or our variables, non-negative because we know we can't make negative desks or tables. And then lastly, we want to set this box up to simplex LP right here. Now once we have that all set, we should be able to go solve. Go ahead and hit OK. And as you can see right here, it did update. We now have a 4 under tables and a 0 under desks. So what this is telling us is that our optimal solution to make the most amount of profit here of $800 is to do 4 tables and 0 desks per week. So again, if you look down here, it balances out. We used 4 hours on machine A out of our total 10, 12 hours here on machine B out of our total 12. So this is a binding constraint here. And then 8 hours out of our total 28 allowed for machine C. So as you can see, we have some slack for machine A and C, as we're not anywhere near the total amount that we had available. However, since machine B was so binding, this ended up being the optimal solution. So just to recap here, we did set up all of our tables and run our solver, and we have a maximum profit of $800. And that is with 4 tables per week and 0 desks per week. And that's how you set up an LP inside of Solver, or inside of Excel and use Solver.